Next, we move on to visualization. So I begin visualization by basically importing matplotlib as PLT and import sunnyborn as SNN. Then I did plt.figure size equals 12 and then 6. Basically what this does is it creates a new figure with a width of 12 and a height of 6. Then I moved on to plt.subplot 1 2 1. Basically what this does is it creates a 1 by 2 grid of subplots, and this allows us to basically to place two plots side by side for direct comparison for the distribution. Then I moved on to SNS history plot, parentheses df brackets price, KDE equals true. Basically what this does is it creates like a histogram showing like the frequency distribution of the housing prices, and then we move on to titling this histogram and then labeling the x-axis as price. Then we move on to plt.subplot 1 2 2, then SNS.history plot and no, np.log 1p parentheses df brackets price, KD equals true. Basically what this does is it creates like a histogram of like the log transformed prices, and np.log 1p basically computes like the natural logarithm of 1 plus x. But it's basically what it does, it transforms the skew data into a more to be more distributed. Then we labeled the log transform distribution of the house prices, and we plotted the labeled the x label as log price. Then we tie plt.tie and plt.show. Basically, we show the two data. So this histogram over here shows that this is like a right skewed distribution, indicating that many of the house prices are at the lower end and fewer at the higher end. And then over here for the log transform distribution of house prices, basically this makes the graph to have a normal distribution, as this is crucial for the model. Basically, as many statistical models assume like normally distributed data, and the transformation helps prevent high price properties from basically like skewing the model. So yeah. Next, we move on to the correlation matrix. So I did correlation matrix is equal to df brackets price, area, bedrooms, bathrooms, stories, parking, brackets correlation. What this does, I selected like the key numerical columns from the data set, and then this basically calculates the person correlation of the coefficient between each of the pairs. Then we moved on to PLT figures equals to fig size 10 to 8, SNS heat map correlation matrix, and then did true, CMAP is equal to warm, and FTM is equal to .2f. Well, basically what this does is basically visualize a correlation matrix as like a color coded heat map, and then we titled the correlation matrix and we like plot it, and then we showed the correlation matrix. From the correlation matrix, we can see like the correlations between each of the numerical columns. So we can see that like the redder it is, it has the higher correlation. The bluer it is, it has lower correlation. So like something like, let's say, store and parking has a lower correlation as compared to something like the bathroom and the prices, which has a higher correlation. So yeah. Next, we moved on to the relationship between like the numerical features and the target variables. So what I did was numerical features equal to brackets area, bedrooms, bathrooms, store, and parking. Basically what this does is it creates a list of the numerical features in the data sets that I want to like analyze against the target variable, which is like the price. Then we move on to fig axis is equal to PLT, subplots, brackets blends, and then brackets numerical features brackets 2 fig size brackets 15 5 times the length of brackets numerical features. What this line of code does is basically it creates like a figure with a grid of subplots of like basically of including like 5 rows for one for each of like the numerical column features, and then 2 columns. Basically this creates like a multi-panel like figure that allows us to compare different visualizations of the same data. Next we move on to for I in feature in numerical features. Basically what this does is basically loops through each of the feature in the numerical feature list over here. Then we move on to SNS.scatterplot, x feature, y price, and df data equal df, and ax is equal to axis, brackets I and 0, parentheses, and then we move on to axis is equal to brackets I and 0 dot settle title, where we where f is equal to the feature and versus the price. Basically, what this does, these line of code does, is basically creates like a scatter plot with like the current feature on the x-axis and the price on the y-axis, as like the scatter plots reveal like the relationship between the relationship pattern between each feature and the house price. Then we move on to SNS.boxplot, x equals feature, y equals price, data equals data frame, x equal to brackets I and brackets 1 and parentheses, and then axis is equal to I and 1 dot set title, price distribution by the feature. Basically what this does is these lines code of does is basically creates like a box plot, basically grouping like the pieces by the different values of each of the features as box plots show the distribution of like the price within like the each category and value of the feature. Then we do plt.title layout, and then we do plt.show. Basically, this automatically adjusts the subplot parameters for like so these are all the scatter. These are the scatter plots, and these are the box plots, and these are like the relationship between these. So as we can see that for area, at least, as the higher area you tend to go towards, there the price often increases, as seen over here by the box plot over here. And then by the price, we can see as there's more bedrooms in the house, the price tends to increase, which we can see by like over here in the box plots where there's a higher range for like the rooms between 4 and 5. Then we move on to bathroom. Bigger bathrooms, more bathrooms tends to have higher prices for housing, as we can see by the scatter plot and the box plot. As same trend over here for the stores and the price, the parking and the price, and so on. So yeah. Next, we move on to analyzing like categorical features. So categorical features equal to brackets, main road, guest room, basement, hot water heating, air conditioning, and pre area and furnishing status. Basically, what this is like creates like a list containing the names of like all the categorical features, basically like the yes or no in the data sets. And then we move on to fixed axis is equal to PLT subplots, length, categorical length, 1 fixed size, 15, 5 times length times the categorical size. Basically what this does is it creates like a figure with like 7 rows, one for each of the categorical features, and 1 column, and then it creates like a vertical arrangement that basically compares like the category. Then we move on to 4i features in enumerant. Categorical lenses basically iterates through each of like feature in the categorical features list. Then we move on to SNS box.boxplot, x is equal to feature, y is equal to price, it has data frame, and axis is equal to axis I, parentheses, axis brackets I dot set title. Basically we set the title for the price distribution by the feature. Basically what this does is it creates like a box plot with like the categorical feature on the x-axis and then the price on the y-axis, and sets the title for the distribution by the feature. Then we move on to plt.title layout and plt.show, which basically plots the categorical features. So these are all the price distribution by the categorical features. So if a house is next to a main road, the price of the house has a higher range as compared to when it doesn't. And then as price distribution by guest room, if it does not have a guest room, the price distribution is like similar to the S, but like has more outliers. Price distribution by the basement. If it has a basement, it's like evenly the price. And then price distribution by hot water heating. If it has a hot water heating, there's a similar range, even if it doesn't or does. Price distribution by air conditioning. If it has an air conditioner, the range for the price is greater than when it doesn't. The price distribution by pre-area. So if it has a pre-area, the range is greater than when it doesn't. And then we move on to price distribution by furnishing status. If it's furnished, it has a higher range in the price as compared to when it's semi-furnished and when it's unfurnished. So yeah.